have taught several universities various courses related to biology and biochemistry. For example, in Mexico, I taught immunology and intermediate metabolism. But my research was in reproductive aging at the University of Oregon, and my dissertation advisor, Arnold Soderwall, happened to be a major figure in vitamin E research. He found that hamsters remained fertile much longer if he gave them increasingly large doses of vitamin E. And although I didn't work with vitamin E myself, that was sort of the background for my research with estrogen, progesterone, and oxidative metabolism.
Okay, so I guess let's. I think probably what we should do. I think most people, and myself included, have I call it a medical understanding of what we commonly know as antioxidants and their function in the body. And I know when we get going, you're going to describe some of the ill effects that some antioxidants can have, because they can kind of work both ways, and how we can best get the best possible antioxidants from our food or other sources that are certainly a lot safer than most of the vitamins that people will buy off the shelf of a health food store, for example, or another whole food place. So would you outline the effects of antioxidants and the body's system of antioxidants and why they are important to our health?
People often talk about the body's innate antioxidant system, and they usually refer to the glutathione in cells and the enzymes that reduce glutathione when it has been oxidized, and superoxide dismutase and catalase are considered to be at the center of our own antioxidant system, with uric acid as a circulating major protection against free radicals. And
that's interesting. Can I hold you there for a second now? Because uric acid is something that I was always led to believe was a cause of gout, and that is that true enough?
It's involved, it being antioxidant. It's also involved in protecting against inflammation, because inflammation involves things that are thought of as oxidative damage.
Okay.
Molecules get oxidized and changed. And so even though uric acid is probably defensive against inflammation, it tends to eventually get crystallized in the process of defending against the inflammation. And so you often find crystals of uric acid
right
in an inflamed joint, but people can have crystals of uric acid in the tissue with no symptoms at all.
Yeah.
And symptoms like gout can occur without the crystals. And crystals of phosphate are probably more common in gout than uric acid crystals, but without analyzing them,
right.
People consider them to be uric acid.
So it's more the inflammation that someone would have anyway, whether it was in soft tissue or joint, that uric acid would come onto the scene to be an antioxidant that then typically associates uric acid with gout.